Imagine a world without mirrors. You couldn't check your hair in the morning, you wouldn't be able to see your reflection in a lake or pond. It's a strange thought, isn't it? Mirrors are so commonplace that we often take them for granted. But have you ever stopped to wonder how they work? What makes these seemingly simple objects able to reflect our image back at us? The answer lies in the fascinating world of physics, specifically in the way light interacts with different surfaces. To understand how mirrors work, we need to first understand a little bit about light itself. The way light bounces off a mirror is governed by a simple rule, the law of reflection. This law states that the angle at which light hits a surface, the angle of incidence, is equal to the angle at which it bounces off, the angle of reflection. Think of a bouncing ball. If you throw a ball straight down at the floor, it bounces straight back up. Similarly, if light hits a mirror at a 90-degree angle, it will be reflected straight back. Now imagine throwing the ball at the floor at an angle. It will bounce off at the same angle but in the opposite direction. Light behaves the same way when it hits a mirror at an angle. This simple law of reflection is the foundation for understanding how mirrors work. You might be thinking, can't any surface reflect light? And you'd be right. Look around you. You can see reflections in windows, puddles of water, and even shiny metal surfaces. However, these reflections are often distorted or blurry. This is because most surfaces are not perfectly smooth. They have tiny bumps and imperfections that scatter the light in different directions, resulting in a diffuse reflection. Mirrors, on the other hand, are exceptionally smooth. They are made by coating a sheet of glass with a thin layer of reflective material, usually silver or aluminum. This coating is polished to an incredibly smooth finish, ensuring that almost all the light is reflected in a uniform direction. This smoothness is what allows mirrors to create such clear and accurate reflections. It's the secret sauce that sets them apart from other reflective surfaces. Section 4. Flipping out. Why mirrors reverse left and right. One of the most intriguing things about mirrors is how they seem to flip our image left and right. If you raise your right hand in front of a mirror, your reflection raises its left hand. But why does this happen? The answer is surprisingly simple. Mirrors don't actually flip images left and right, they flip them front to back. Imagine standing in front of a mirror and touching it with your nose. Now, imagine that the mirror is a window and you can walk through it. What would you see? You wouldn't see your reflection facing you, you would see the back of your head. This is because the mirror is reversing your image along the axis perpendicular to its surface. It's this front-to-back reversal that creates the illusion of a left-right flip. Our brains are used to seeing objects flipped left to right when they rotate, so we interpret the mirror's front-to-back flip as a left-right flip. Section 5. From Ancient Reflections to Animal Awareness. Mirrors have a long and fascinating history, dating back thousands of years. The earliest mirrors were simply pools of still water or polished obsidian, a naturally occurring volcanic glass. As technology advanced, people developed more sophisticated methods for making mirrors. The ancient Egyptians, Greeks and Romans all used polished metal mirrors, often made of bronze or silver. Mirrors have always held a certain fascination for humans. They allow us to see ourselves in a way that is otherwise impossible. This self-reflection has played an important role in art, literature, and even psychology. Interestingly, humans are not the only species that can recognize themselves in mirrors. Some animals, like chimpanzees, dolphins, and elephants, have also demonstrated self-awareness through mirror self-recognition tests. This suggests that the ability to understand reflections may be linked to higher cognitive functions.